Okay, this one is number 9, and it looks pretty interesting. Zach is planning to invest up to $45,000 in corporate and municipal bonds. The least he will invest in corporate bonds is $6,000, and he does not want to invest more than $27,000 in corporate bonds. He also does not want to invest more than $32,116 in municipal bonds. The interest is 8.8% on corporate bonds and 6% on municipal bonds. This is simple interest for 1 year. What is the maximum income? Okay, so that is our problem, and now we're going to extract some of the data. So it says that Zach is planning to invest $45,000 altogether. So his investment in one plus his investment in the other will be $45,000. So corporate bonds plus municipal bonds is going to be $45,000. Okay, so we're looking at what amount is he investing in each one. And then the least he will invest in corporate bonds is $6,000. So $6,000 is less than what he's going to invest, and he does not want to invest more than $27,000. So that'll be less than or equal to, okay, so both of those are less than or equal to $27,000. And I'm writing this on the board so we can look at it. He does not want to invest more than $32,116 in municipal bonds. So municipal will be less than or equal to $32,116. And then we've got 8.8%, so corporate times 0.088 plus municipal times 0.06 will be his interest. Okay, remember that interest is principal times rate times time. And since we're doing this for 1 year, simple interest is just going to be the number he invested in corporate bonds times the interest rate of corporate bonds, and then the amount that he invested in municipal bonds times the principal of municipal bonds. And we're trying to maximize this equation. So we'll say his interest equation is this. So this is what I have right now. Let you see the board that has all of the pertinent data on it. And now we're going to have to look at this and actually come up with the equations and see if we can figure out what this is going to look like. Now, when we're looking at this, we've got some equations that we can graph, and we could let the corporate bonds be on the x-axis and the municipal bonds be on the y-axis. That's fine. And then we've got some constraints that we have to take into consideration. So when I'm looking at this, I'm not going to worry about that interest equation. I'm not going to worry about graphing that at all. I'm going to look at what are my constraints here. And I'm just going to make everything on here, when I'm going to graph it, let's see how we can graph it reasonably. We're going to graph everything in thousands, of course. And probably going to have to make the graph, to make it reasonable, is going to have to be something like by threes. So we're going to have to do everything by threes and let everything be in thousands to be able to see this. So because I don't want my graph to have to go up to 27, but most everything is divisible by 3 except for the 32,116. So that probably will work. All right, so this is not going to be as bad. I decided to go with 5 for my grid. It's not going to work out perfectly, but it'll work. So I'm going to let this be my C-axis and let this be my M-axis there, so that my corporate bonds are along the X. And remember that corporate bonds cannot be less than 0, and neither can municipal bonds. So we already have a constraint there that 0, 0 is going to be our very lowest point over here. And we're never, this is a first quadrant graph. So if I have the C and the M for corporate and municipal, and they equal 45,000. We're saying that's 45 for now. We're dividing everything by, everything is in thousands. And so if I let, in this equation right here, if I let C equal 0, then M would be 45. Okay, 1,000. So I have, if C is equal to 0, then M is 5, 10, 15, 20, 25, 30, 35, 40, 45. So that would be a point. If M is 0, then C would be 45,000. So if M is 0, 1, 2, 3, 5, 10, 15, 20, 25, 30, 35, 40, 45. So I'd get this point, okay? If I let C be something nice like a multiple of 5, so if we let C be 15,000, then wouldn't the M have to be 30,000? Okay, so if I let 5, 10, 15, then the other one has to be 5, 10, 15, 20, 25, 30, and that would be about there. So this line winds up being a constant line that goes all the way straight from one to the other, okay? And this is, he wants the two to add up. This is what he wants to invest, okay? And it says he is planning to invest up to. So when I'm writing these equations, shouldn't I have really made that a less than or equal to right there instead of an equal to? He wants to invest up to 45,000. So that means that we have a less than, and that means that if we are going to, we'd have to be shading underneath this area. So we'll just do a little mark there. We're shading underneath to show that it's less than or equal to 45,000. So then that's one line. Then we have the C line. Okay, the corporate bonds are going to be greater than or equal to 6,000, but less than or equal to 27,000. So we have a region where he is wanting to do these. So we're going to do these in blue. We'll do the second one in blue here. And so our C is our x-axis there. So what we're going to do is 6 and 27, because we're using everything in thousands. And we say, okay, so 5, 6 would be about right there. And so we're going to draw a line up through there. That's my 6,000 line. And then 27,000. So 5, 10, 15, 20, 25, 27,000 would be that constraint line that the C is going to be equal to 27. So that's an X line. And so this, it would be in here, wouldn't it? It's in between these two, but it's got to be below the other line. So we are narrowing down our region of feasibility, aren't we? And then the last one we'll do in red. And he's saying his municipal bonds are going to be less than 32,116. So we're going to take red, and our municipal bonds are on the y-axis, 32,116. So 5, 10, 15, 20, 25, 30, 32,116. Okay, so we have, and that's less than, so we have our, coming down here would be our region of feasibility. So let's look at our region and say, where are our points that we're going to have to look for to see how to maximize this investment for him? Okay, so we had the black that we started out with, okay, was the first equation, and it's going up here, and then the blue lines come through there, so the red is going below here. So in other words, this part was red also, but it's not going to matter. So everything below that line was red, but we don't care about that part. We just care about this feasible region where we're shading all three parts. Okay, so let's look at our special little spots here. So this one would be a special spot because that's the beginning of the whole thing. And everything down here is both red and black because the black goes on all the way through here, right? The black goes all the way. And the blue is in between these two blue lines. And then the red is everything below there. So that would be one of our lines there, a point. And then this intersection between the black and the red. And then this one right here between the blue and the black. So it's a 1, 2, 3, 4, 5-sided figure here. And so it's a little bit more complicated, but let's see how many of these we can already name. Okay, so let's put our points up here. So this point right here, remember, was 6,000, and it's right at the 0 line, so that was 6,000, 0. So 6,000, 0. We're letting the C be the X. And then this point right here, oh, we didn't mark this one. This point right here would have been the upper right range, so that's 27,000. And so that would be 27,000 and 0. Okay. And then this one right up here is the intersection between the black and the blue. But the blue, we know, is 27,000. So that would be the X part, would be 27,000. And we have to plug in to find out what the Y part is. So I'm going to just leave that for just a second. We'll come back and look at what that Y value is. Oh, well, we can actually look at it now, because if we're looking, that black line was this first one. Okay, so if the C was 27,000, then the M would have to be 45 minus the 27,000. And that's going to end up being 8 and 1. Okay, so 18,000. I believe I've got it right if I haven't messed up my math at all. So that will be 18,000 as the other one. And then this one is also a possibility. Our maximums often occur on these lines where we actually have to figure something out. Okay, so this one is up here. Remember, with linear programming, our maximum will always occur at the vertices. So this one up here is going to be, it's going across at 32116. So the Y value is 32116. Okay, and then we have to find the X value that's going to go with that one. And since the Y is the M, then we could put that one in here. So now let's erase this one since we already know what that one is. And let's put the M is 32116. So now we got to figure out what the C will be. We subtract here. So 32116. We're going to have to come over here at 4 and borrow and come up with a 4 and a 8 and an 8 and a 2 and a 1. Okay, so that means this X value would be 12,884. And then this last point again is going to be 6,000, and this line here was 32116. So we just found the coordinates of our 5 points. Okay, now granted, this takes a lot of time, but just think about, okay, he's trying to make an investment of $45,000. Don't you think it might be worth it to him to maximize that investment by properly doing the math, or at least having somebody that can do the math figure it out for him? If you wanted to be a linear programmer where you do this, this would be a great business application. Some folks maybe have the money, but they don't have the math knowledge to maximize that money. Okay, so we have 5 points. These are our 5 points, and we have to plug our 5 points into the equation. Remember, the equation is our interest formula down here at the bottom. That's our objective equation that we're trying to maximize. So we have to try each one of these points. Now, which one do you think is going to work? The ones that are probably going to work is either this one or, now this, yeah, one of these. Usually not the ones that have zeros in them. So we're going to plug each one of those in. All right, so the cool thing was I really didn't have to do 3 of these. I could see that this one was going to yield less than this one because they both had zeros on the end. So I didn't need to try that one. I could see that there was a 27,000 and 27,000, and this one was going to be smaller than this one. And then when I looked down here, I could see that 2 of them had the same Y value, but this one was half of this value. So basically all of these were in my feasible region. So I'm going to pick the 2 that looked like they could yield the most, which was these 2 right here. So I figured out this one, and then I realized later I really didn't need to even try it. So these 2 were my ones that looked like they could be the maximum. And I just cranked them out using this formula, plugging them in for the C and the M. And I got this, which turned out to be 3,456. The second one turned out to be $3,060.75. So the winner was this one, which was 27,000 as corporate bonds and 18,000 as municipal bonds. And if you had that kind of money to invest, wouldn't you want to invest it in such a way that you're going to make almost $400 more in interest a year than you would if you invested it wrongly? Okay, so they're both good investments, but I mean, one was a lot better than the other one by almost $400. So I would choose the one that was a better investment. So this is a good example of linear programming, and all businesses have to do this at different times because they have decisions that they have to make based on constraints, based on things like profit and loss and overhead and all of these things. And so being able to do this linear programming is very, very handy. Okay, so we are going to just do 1 or 2 more problems, and we're going to close this down, and this is our last video, so we're almost there. Now we're going to graph a system of inequalities, and the one we're going to do is y is less than or equal to negative x squared, and x plus y is greater than or equal to negative 2. Okay, so the reason we're going to do this one is this is now not linear anymore. Okay, everything that we're doing is not linear. This one on the top is a upside down parabola, and then this one is a line. So we're going to graph the intersection, or the intersection of the 2 shadings will be what we're looking at. So this is the first one that we've done that was not linear in this section. So here we've got a negative x squared, which is a downward facing parabola, and it should be right here going through 0, 0 and going down like this. Okay, and then we're shading y is less than, so that's going to be down here inside the parabola portion here. And then we've got this line, which I'm going to graph with x and y intercepts. If I let x be 0, then y will have to be -2. So we have 0, -2, about there, okay? And then we've got, if we let y be 0, then x would have to be -2. And so we'd say x is -2 is about there. And then we've got this line going down here that's going to go about like that. And we're shading, if we put the y, so if we put this in slope-intercept form, wouldn't it be y is greater than or equal to -x minus 2? Okay, and we do have a slope of -x, and we do have a y-intercept of -2, and y is greater than, so we'll get our black marker here, and we'll shade greater than the line, and we should always check with our 0, 0 test point. If we plugged in a 0, is 0 greater than or equal to a -2? Yes, it is. Okay, so now we're looking at the intersection of these two graphs, which would be right there. Okay, so that is what they have here on the PowerPoint as well, just like that. Okay, except theirs is a little bit neater than mine. And this is the last problem of this PowerPoint and this class. All right, when we have an absolute value, remember it's very easy to take the absolute value, because this was what we had here. Now we're going to play with the equal sign, not the greater than or equal to sign, for a minute. So when I take the absolute value sign off, I can say it's equal to 2 or -2. Because remember, the absolute value sign is over the whole x plus y. So I can write it like this. Now I know that 2 is not equal to -2, but this just reminds me that there are two options. So if I look on the right hand side over here and say, well, x plus y is 2, then 0, 2, and 2, 0 would be the x and y intercept of this line on this side. And then when I look at this line on this side, then 0, -2, and -2, 0 would work. And so I have two lines, and here are my two lines here going through. And then I have to think of how to graph them. Remember, when I have greater than or equal to a constant, it's going to go on the outside of the lines, and you would plug those in with test points to figure out which way the lines are going. And I think we have very thoroughly covered all of 6.7, and I am very tired, and I'm sure you are too. And your test, your final exam, is coming up. Some of you are having it in 2 days. So hopefully you will find these PowerPoints and these videos very useful. And I'm wishing you all the best as you study hard, do well. This is Mrs. A, and may God bless your day.